Hi physicists, and welcome to my video on sound intensity. So you need to watch this video if you're doing the medical physics topic in AQA A-level physics. If you're not doing the medical physics topic, then you don't need to watch this video, but you might still find it useful. So let's get started with what sound intensity actually means. So sound intensity is the power per unit area delivered by a sound wave. Because it's the power per unit area, we measure it in watts per meter squared. And we can calculate it using the equation intensity is equal to power divided by the area. Now, we have to be quite careful with that area because this isn't just your basic inverse square law. Because when we imagine that a point source of sound releases sound waves, they're going to spread out in all directions. So it's going to spread out in kind of a sphere. So actually the area we need to use here is 4 pi r squared because that's the surface of the sphere. Now, if you've lost me a little bit there, I'm going to link some TikToks into the description of this YouTube video so that you can go there and check out me using this equation for some exam questions. But what you need to know is that the minimum threshold of what a human ear can hear is about 1 times 10 to the minus 12 watts per meter squared, okay? So that's the minimum sound that a human ear can hear. But specifically, this has to be at a frequency of 1 kilohertz, okay? We say this specifically at a frequency of 1 kilohertz because actually the ear's response to frequency and loudness changes. We're going to look at all of that in just a minute. But what you need to know is that this minimum threshold is 1 times 10 to the minus 12 at 1 kilohertz. Now, the human range of hearing is anywhere between about 20 to 20,000 hertz. So this is kind of right in there. Now the pain threshold, so the maximum intensity an ear can take without feeling pain, is about 1 watt per meter squared. So actually, when we're talking about intensity of the human ear, we've actually got this massive range. And so what we find it easiest to do is to use a logarithmic scale to talk about sound intensity. So if I want to find the intensity level, I need to use this equation here, which is 10 log to the base 10 I, the intensity, over I naught. I naught is the minimum threshold. So this here is I naught. It's a constant and it's given to you on your equation sheet in your exam. But the reason it's so helpful for us to use this intensity level equation here is because the ear's response to sound is logarithmic. It's not a linear scale. So if I hear something at double the intensity, I won't necessarily hear that as being double the loudness. So this is why we use this intensity level here. I like to think of that as being like the loudness that I hear. Now this is measured in bells, but the most common unit that we use for intensity level is decibels, which is written just like that. You might well have seen it before. Now, if we want to rearrange this equation, we need to remember our log rules, okay? So the log rule is a to the x equals n, then therefore log of a to the n will equal x. If you've never used log rules before, again, I'm going to link a couple of TikToks where I use them to solve exam style questions so that you can get an idea of what we need to do. But you do need to remember this log rule if you're going to rearrange this equation. Right, so that's intensity level. So let's now talk about the human's response to intensity level in terms of frequency. So we don't actually hear all frequencies as being the same loudness. The ear is most responsive, so we hear the sounds the loudest between about 2 kilohertz and about 5 kilohertz, with our peak of sensitivity being at 3 kilohertz. So normally when we do an intensity level versus frequency graph, our x-axis is logarithmic, okay? That's because if we did it going from 0 to 10,000, we'd be going on forever and ever and ever. And actually the interesting bit happens about here in the middle. So the ear is most sensitive at 3 kilohertz. So that is where we're going to hear those sounds as being the loudest. So if we go on 3 kilohertz, we're about here. If I draw a graph like this, something like that. Now, This is what we call an equal loudness curve. So this is where the human brain will perceive all of these sounds to be of the same loudness. So these frequencies in the middle, where the ear is most sensitive, can be played at a lower intensity level because I'm going to perceive them as being the same loudness, okay? So the intensity level scale here is in decibels, and this is where I would perceive all of those frequencies to be the same loudness. So the thing we need here is most sensitive at 3 kilohertz. Right, you need to know what happens when you age and what happens if you damage your hearing due to prolonged exposure to loud noises. So, as we age, the highest frequency that we can hear decreases, so we might not be able to hear all the way up to 20,000 hertz anymore, but equally, we will need to have a higher intensity level to hear every single frequency. So someone who's a bit older, their graph might look something like that. That to get the same loudness or perceived loudness, you're going to have to play all of these frequencies at a higher intensity level, okay? Now, someone who has damaged their hearing due to loud noises, what you need to do for them is you need to draw a bump on this graph at 4 kilohertz because that's where they're going to get the most hearing loss. So they're going to have reduced hearing over all frequencies, but they're going to get a bump here, and that's going to equate to 4 kilohertz because that's where they're going to have the most hearing loss. It's very specifically at 4 kilohertz. Right, how do we produce these equal loudness curves then? So what we do is we sit someone down in headphones in a soundproof room. We play them a reference tone of 1 kilohertz. Let me get the right colour pen. There we go. We're going to play them a reference tone of 1 kilohertz. And we adjust it so that we've got that at like a sound. And we use that as our reference sound, okay? We then play a sound of a different frequency, and we adjust the intensity level until the person that you're testing this on says that it sounds like the same loudness, until you get the same perceived loudness. So this is how we find these equal loudness curves, is that we sit someone down, we play them a reference tone, and then we play them lots of different frequencies until we get all these different loudnesses, and then we can plot them on a graph. So actually, if we played something about, let's say, I don't know, 100 hertz, I'm going to hear that as being a lot quieter, even if it was actually played at the same intensity level. Right. So the problem it comes when we're trying to measure sound intensity, because we're looking at like a bar or a pub for licensing, or we're looking at a concert hall or something like that, because sound meters don't respond in the same way to sound as the human ear does. So what we do is we put what we call an A weighting filter onto our sound meter. And that means that filter will respond in the same way to the human ear to sound. So very low frequencies or very high frequencies can be played at higher intensity without them bothering people. When we are looking at something that's been measured using an A weighting filter, it's measured in dBA, so that we know that it was measured using a weighting filter. Right. Thank you very much for watching this video, and I really do hope that you found this video on sound intensity useful. Don't forget that if you need any more help or you want the best chance at improving your grades, to check out the link in the description of this video, which will take you to the website where you can look at joining in with our live courses, which are really good fun, and we go over all of this medical physics content, okay? Whilst you're there, you could also subscribe to this channel so that I can carry on making more videos like this. And don't forget, if you want the notes for this topic, check out my resources on the My EdSpace website. Thank you very much. See you soon.